Enumerating objects in the pipeline. What do you do when you've got a bunch of objects and you want to perform some action against each one of them, and you don't want to really have to write out an entire programmatic style script? You need to go through those objects one at a time and do something with them, but you want to do it in the context of a pipeline. Well, that's what I'm going to show you how to do. Here's how we'll tackle this. We're going to start by talking about a command called for each object. That's going to actually take multiple objects in the pipeline and allow me to run some action against each one of them in turn. We will talk about some performance cautions because we're starting to get into one of those areas where there's like 50 ways to accomplish the task, and it's important to consider all of them as well as consider their performance. So I'm going to show you how to actually check the performance of different kinds of variations or commands. We've also got some syntactical differences to talk about between the different versions of PowerShell, so let's get started. Now, I'm hoping you remember back when we talked about objects and methods, I showed you that one way to execute a method of an object would be to get a bunch of them, such as grabbing all of the currently running processes, and then you could refer to a single one. You know what? Let's not shut down anything crucial. Let's run a copy of Notepad and try that again. Procs equals get process, and let's just grab Notepad. Well, obviously, procs right now only contains that one object. And if we try to access via 0, we don't get that because it's only got the one object. So what I could do is just procs dot kill to execute the kill method. And you'll notice down on my taskbar that Notepad went away. Let's run a couple more notepads. Now, I'll get them again. This time, obviously, since there's more than one, procs is going to contain multiple objects, and so I can refer to those by their index number, and then if I wanted to kill them, I could just execute that method against each one of those. Now, see, once you've got this is kind of like the whole idea of automation, right? It's easy enough to do one thing manually, just by, if I needed to kill one copy of Notepad, right-clicking on the icon and closing it would probably be the easiest way. It's when you start having to do things more than once that you want to automate. Automating like this is really not any different than just doing it manually. So back then when I showed you that trick, I told you that in a couple of nuggets, I would show you a way to kind of have PowerShell do that for you, and we're there now. So let me launch those copies of Notepad again to get 3 of them up and running. Now, obviously, this is not all about terminating Notepad. This is about performing a given action against multiple targets all in a single operation. The targets we're playing with right now are obviously processes, and the action we're doing is terminating them, but it's the idea that we're doing something to multiple things at once. So what I'm going to do is get process minus name Notepad. Just quickly make sure that's all that comes back. And I'm going to pipe those to a command called for each object. Now, for each object accepts a process script block, which means it goes in curly brackets, just like that. And in here, I put whatever I want to do with each, in this case, process, because that's what was piped in. As in many cases before, we get to use $_ to refer to whatever was piped in. Now, in this case, it's a process object being piped in, so I can execute the kill method. Boom, and they're all gone. Let's run them up again. Now, the process parameter is positional. You'll almost never see anyone actually type minus process. They just provide this script block in the first position. Most folks will not type out for each object. If they're being nice to you, they'll use the alias for each. If they're not being nice to you, they might use that alias, which means the same thing. And of course, if they're really, really getting shortcutty, they'll probably use that positionally, and instead of get process, they'll use its alias, and now no one can read it. By the way, this is another example of an error message that you should have expected. Get process is returning an error here because it couldn't find any processes named Notepad, so it threw that error. That's okay. I don't have any copies of Notepad running, so I should have expected that error. It's just another example that reading the error message is a way to make sure it's not going to mess you up. Now, Let's talk a little bit about performance on this dude. Go back to the full version. This is definitely a great trick. It's definitely a good technique to use. It is not the fastest performing technique in the universe. And that's because what really happens under the hood with Windows PowerShell, now let's say I still had 3 copies of Notepad running. So this is going to produce 3 objects. Now it's going to start streaming those objects down the pipeline as soon as it starts producing them. So the first object is being sent over here even as the second object is being created in memory. The second object follows as the third object is being created and so forth. So you can kind of think of these pipelines as being a little multitasky. This is running and it's producing objects, and as it's doing so, this is running and dealing with them. Well, as it's dealing with them, it has to execute this script block once, which means under the hood in memory, PowerShell actually has to look at this. It has to parse it. It has to decide what it's going to do with it, how it's going to execute it. It has to figure out what that $_ refers to and go through that object. And it has to do this entire process once for each object that got piped in. Now, in this case, we're executing a simple method against 3 objects, probably not a big deal. But kind of my point here is that for each object it's probably the least performance efficient way to do this. When you need to perform a task and you find yourself using for each object, just take a step back and see if there might be another way to do it. For example, that would accomplish exactly the same thing. Now, let's go ahead and run a few copies of Notepad again, just to make sure that it does the same thing. Watch the taskbar. There they go. That is actually probably running faster than the for each object version. But you know what would probably run even faster than what I just did? That's probably the fastest version, because now it doesn't need to convey anything down the pipeline. So as much as possible, you want to think about that for performance. Again, in this little example, does it make a huge difference? Maybe not. But as you start working with more objects and you start performing more complex tasks with them, it can make a difference. Now, how can you tell if it's making a difference? Well, here's a great way to see. Measure command. Let's take a look at his help. All you have to do is give this an expression, and it will actually run the command. So if you're asking it to do something potentially dangerous, like killing processes or, I don't know, deleting users from Active Directory, just keep in mind, it's going to happen. This isn't a test mode. What this is simply doing is allowing us to measure it. So expression, notepad, notepad, notepad. And then I'm going to get process, name notepad, and pipe it to, for each object, $_kill. So keep in mind, those semicolons there are allowing me to separate out my commands. So this has actually got 4 commands inside that expression. Here's the first one, the second command, and the third command. Those are all running copies of Notepad. And then all of this counts as the 4th command because it runs in a single pipeline. So when we hit enter, this is going to tell me how long it takes to run that. All right. That in and of itself is not meaningful information. What we're actually going to want to do is compare that to some of our other options. So now let's get rid of the for each and change it to stop process. And we'll do it one more time where we just stop process minus name notepad. So let's see what we've got going on here. The first version took 19.6783 milliseconds. The second one actually took a little longer. It took 21.5 milliseconds to do it that way. So it turns out piping it over to stop process was actually a little slower. And this took 20 milliseconds. Now, I'm not really being a good tester here. If you think about this, and this is why I wanted to do this way, because I'm curious to see what the difference is. Starting these 3 copies of Notepad could be running these different versions at different speeds, just depending on how Windows is feeling about starting up different copies of Notepad. So we should probably do that as a separate step. So this is going to be our real test. I'm going to start 3 copies of Notepad. And then I'm going to ask measure command to just measure the terminating of those processes. So I'm going to get my pen here and get a piece of paper so we can write down what the... Who has to move all the Post-it notes in this office? All right, so I want to write down the numbers here. So here we go. Here's the first one. That was, you see the difference? So we were spending about 18 milliseconds just starting Notepad before. So total milliseconds on the for each time is 2.1919. Let's start those copies of Notepad again. And now let's measure command. And this time we're going to get and pipe to stop. See, that actually did take twice as long. So 4.6797. Let's start the copies of Notepad one more time. And this time we will just do stop process. It's always fun to see which of these works better, because sometimes you think one's going to be better and one isn't. And that took, stop by itself was 3.1816. So in this case, really weirdly, it was faster to go get all of the processes and actually enumerate through them using for each object and execute the kill method against each. I will say this, I've seen a number of occasions where a commandlet like stop process runs a little slower than if you were to execute a method like kill against the base object. And it's probably just involving the additional code and overhead involved in getting the commandlet itself up and running. When we did this first version with for each object, we only had to run this one command, and essentially we wound up running that one the same each time. So that was probably a wash. The real difference is here we didn't have to start a second command. We already had the object, we just had to execute its kill. It's always worth testing these things though, because you'd never really know exactly what's going to be faster because of all the stuff that happens under the hood until you really, really dig down there and try it. What I'm saying is, be aware that there's a difference. This is how you can measure that performance, and that's how you can decide what's going to be best for whatever situation it is you're trying to deal with. Now, PowerShell 3 offers some additional syntax options to for each object that I just want to briefly show you. There we go. Let's try this exact same thing that we've been doing. I'm going to launch a couple copies of Notepad. First of all, you can still do the same get process name Notepad. Get little tab completion there on the process names. You notice that? Note tab, because it's able to quickly enumerate the running processes so that it can tab complete that name for me. I love that trick. We can still use the alias %. We can still use for each. We can still use for each dash object. And instead of $_ you can also put PS item. So there's our method to kill those. Let's get those back up and running again. You'll notice that there's kind of a simplified syntax. Now, one way to do this, let's just put ID, for each object ID. What that's actually doing is enumerating through each one and getting the property ID. This is essentially the same as using select object minus property ID. The difference is this is just pulling out values, while this is actually creating an object with an ID property. So I guess it would be more equivalent if we said expand property ID. And then we get that same thing as when I did for each. Let's try it with a method. We've got those copies of Notepad running, so let's do a for each kill. And that kills them. You'll notice in this syntax, I do not put the parentheses after the kill. I don't have to. Now this is referred to as the simplified syntax of for each object. Here's a downside to it. Let's get copies of Notepad. Actually, we'll just work with the existing processes here. I'm not going to kill them. We'll get all the processes. I'll send it to for each object. And let's say that what I wanted to do was print an uppercase version of the process's names. So I know there's a name property, and I know it's a string, so that means it should have a toUpper method. Yeah, that won't work. If you put this back in the curly brackets and use $_ or $PS item, then you can do that. So just a couple of little syntactic differences that you have to play with. One thing I do want to show you though, let's run Notepad 3 times. I'm just curious. Let's measure object, and the object, expression, measure command. Haha, there we go. Let's measure get process minus name notepad pipe to for each object, and this time we'll use the new syntax and just put kill not in curly brackets. I'm just curious if this is going to make any significant performance difference. Yeah, actually, back when we did that with for each object in the curly brackets, that operation took 2.1919 milliseconds. So it looks like we shaved off about 1/10 of a millisecond. So potentially this technique of just putting the method name here is a little quicker than putting this in curly brackets like we had to do in version 2. So that's just always, again, interesting to see some of the differences there. Okay, so now you've met for each object and his little friend, the %sign alias. We discussed some of the performance cautions. Just be aware that for each object is not always the fastest way to do it, but sometimes, as it turns out, it can be, and now you know how to measure that when you're testing so that you can figure out what the fastest approach is. And we've talked about some of the syntactical differences between different versions of PowerShell. I hope this has been informative for you, and I'd like to thank you for viewing.